Hi, this is Man, Server Boy UK. Today I just want to step over 3 basic steps which I normally use over the last 2 decades on resolving Linux problems, server problems obviously. When say customer said, oh, my web server is not working, email is not receiving, that sort of thing, the first thing for say you want to see the servers up or down, and like my server here is a test server, so it's up. Then I would get into it if I could get into it. Now that's the tricky part. In terms of cloud management, all the servers are in the cloud. It's not like you in the old days where you could walk over a console, TTY, that sort of thing. That's the best, of course, but you don't sleep next to your servers, so unfortunately, which I would love to. Then it all depends on whether you can get control of it. Of course, there are many different ways, depending on your bare metal. If you have a bare metal which has a second NIC or something where your data center could provide you with a remote console access, that's fine, then you could get to the console. Or in my case, I use libverb, which is libverb. So I basically use KVM, and I could start my my SSH tunnel over to the bare metal. From there, I use the libverb control to get access to the console of my KVM. That's fine also. But in the case that you could, like me now, I could get to the virtual machine, the server that my client is running the application on, then fine, then I don't need the bare metal layer to play guard. I could directly control it. So the first thing when I got onto there is I would do a dmessage. That's the first thing. I've been using it over the last 20 something years, and I don't know why, just every time I got used to it, and I just want to see what the kernel messages are coming. It's like a pattern matching thing, and normally you see the screen here it depends. I don't read every line. It just now the screen set is normal. I mean the kernel message, it seems to me normal. When it's not normal, sometimes you will see, most of the time you will see segmentation fault, set fault, things like this, with a whole bunch of hacks and core dump and things like those. So that means what? That means is some processes when dead, it was crashed. It could be the processes that your client can bring about, could be a postfix process, Apache process, so on. And there are mostly 2 reasons that they would die like that. One is out of memory, and the other one is something bad happened, like a hacker that triggers a bug in the server code, the application code, and cause a invalid access to certain memory buffer. That's a could be a segmentation fault. Now that's when it calls segmentation fault, is you have to know what is the Intel segment in terms of their CPU architecture. So this all go back to hardware, at least the machine level thing. It's a good thing that nowadays, even though there are containers, they're all abstractions. We don't live our life, our stack, too far away from the underlying layers, eventually leading down to the hardware that implement these things. So it's always good to have an idea of what this means in terms of how the hardware handles different layers on top, and so on. So these are all abstractions, and somehow we have to digest these abstractions and flatten it to the extent that we can understand how things fall flat, if that happens. So dmessage gives you an idea if that thing is working in terms of the healthiness of your server in a big general sense to start with. Then the second command is I run a top. I haven't even looked at the processes or the complaint about service first. I just look at the general system vital signs. So the top gives you an idea of how your system is performing in general. So like now, you look at it, it's fairly stable. Nothing's running much. It has some DB process, some system threads. The low average is 0. It's fairly idle. You look at the free space of memory here, because of the buffer cache mechanism from the old times. Linux in general, like Unix, will always allocate most of the available memory, so it is for IO buffer, for paging, many things. So you don't see that much memory free anyway. So that's it, and it seems to me that it's all right. So the second step is just to have an overall idea if the system is very busy or some processes are hogging memory. So that at least gives you an idea if it's normal. Now this is normal. So the third thing, I would take a look at the log. So depending on which distro you're running, I think this one is a CentOS 7, pretty old. Not too old, but one generation older. Now CentOS is end of life, so yeah, I could upgrade this. Maybe we have a video on how to migrate this to, say, Ubuntu. But anyway, now I have the message file, so I would just tail it to see what are the latest system messages that would particularly catch my attention. Of course, right now it doesn't show anything particular, so that means it's normal to me. But again, this is not the system that I hypothetically said my client is complaining, so it's not in a problem state. Right, so messages. So we've gone through the message, which is the kernel messages. We have look at top, which is the normal, the overall system performance situation. We have system log, which is the var log messages. So this gives you an idea what is going on. So the system now, you have a general profile, then you go to the specifics. If it's about Apache or web not responding, then now you get in to see if the processes are running. So I would just check if the process is running. Of course, in this case, the process is running. All right. Then you do a next step also to track if the ports are there listening. So the ports are open, it's listening to port 80 and 443, the HTTPS port. So it seems to be working fine, it's sound. In the case that is not, then and there's no process running, no such processes running, so that could possibly explain why your customers or your users are saying they can't access the web on this server. So that if that's the case, then you have to find out why. Normally you should have noticed a log message in var log about what happened, and might even know from the message that the kernel actually killed or crashed the HTTP process because of not enough memory or so on, and things like those. So those are the scenario that I mostly encounter in the years, out of memory thing and blah 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 and so on. So that is the typical steps to resolve a problem. Now we haven't come down to resolving it yet. So now if this is dead, then what's the next thing? It depends. Now if it's a kernel crash or something more than just the application system crashing, something that would involve the kernel itself is giving out error messages, that I would suspect more problems. It could be serious, like hacker-induced bugs in certain release of Linux distro, or it could be very simple, just simply because it's unlucky. You run out of resources and get into certain resource-related issues. So I would probably just restart the whole system if the user is not complaining and if there's a downtime possible, just to restore it. Now, of course, it comes down to many times that before you restore anything, you have to worry about if you lose data, if you restore it, and if the system could actually come back up. If you are not sure, if you cannot be assured that these conditions could be met, then you might as well try to restart the service first. The reason I said we restart the system because of kernel error is because I have a feeling that even if you restart the services, if the kernel is having problem and it's not in a stable condition, then it might not, even if you restart the service, it might not be stable. So that's the reason why I want to restart the system. Now, in the case you have a peer system like a B system, that if you can restore your A system, this one, you can still go to the backup. That's fine. That's a safe, sound approach. Also, you might take the opportunity to back up the SQL database and things like those before you do anything further. So data are always the most important thing. You could reinstall a system, you could rebuild everything, but the data are not easily recoverable. So backup data before you do anything if the downtime allows, and things like this. So then somehow it will resolve the problem. So that's about the basic steps, and these are most of the time they work. And when I get to repeat this more and more in the career, I start to develop a feeling, like a system sense towards how the system works and how it behaves. It's really like you live a long time with a certain person, then you know how when there's something wrong with that person. It's the same sometimes that happens to machine, that our software behavior in general is software are with certain complexity, and even though it's complex, when you deal with that for a long time, you start to develop a pattern of like a sense of the patterns that they would behave, and that's when you have a grasp of how to administer a system. So other than those typing and commands and manuals and things like this, it's like a surgery. It's like a fight against time when system downtime is important. So you don't go through. You try to narrow down the problem like a tree search or something. So you try to traverse down the path of possibilities from a vast inverse tree down to a certain root where it originates. Then that's the approach, where you start from the wide base and quickly you narrow down into certain possibilities from experience, from observing the patterns of the behavior of the software, and so on and so forth. So yeah, that's sometimes not very complicated, and hope this little sharing helps. You might have, of course, a whole lot of different methodologies, but that's the way I do it most of the time. Thanks for listening. Enjoy your day. Cheers. Bye.